Alright, so I'm doing example 6 in the note, repeated eigenvalue case, special case 2. Now for this example, I have already found the eigenvalues, okay, that is in the previous video. Again, if you're struggling, take all the notes and do all the exercises regarding eigenvalues and watch the video. You can find a video for every problem, okay, and learn it and pause the video and do it and learn by yourself, okay. You can practice a lot of problems. So here let's first take the non-repeated eigenvalue, which is 0. So to find the eigenvector, we write A minus lambda I matrix. So A minus 0 I is A, right? So we want to solve AK is equal to 0 because lambda is 0, lambda times I is 0. So so this means the equation is 5, negative 4, 0, 1, 0, 2, 0, 2, 5, little k1, little k2, little k3 is equal to 0, 0, 0. Now we write the Gaussian, we use the Gaussian elimination and we write the augmented matrix 1, 0, 2, 0, 2, 5. Now pause and think, what is the first step? The pivot position is 5, non-zero, good, but I would like it to be 1, so I will do a trade. So I will swap R2 and R1. So I get 1, 0, 2, 0, 5, negative 4, 0, 0, here 0, 2, 5, 0. Now to create 0 at this 5, we automatically have 0 on the bottom, but to create 0 at 5, we would multiply the first row by negative 5 and add it to the second row. So what I get is 1, 0, 2, 0, here 0, here negative 4 because 0 plus negative 4 is negative 4. 2 times 5 is 10, 10 plus 0 is 10, 0, here 0, 2, 5, 0. Okay, now here what I can do is if I look at the second row, I can divide the second row by 2. Let me show you why. We get 1, 0, 2, 0, here 0, negative 2, 5, 0. And now I guess you can see it. Because now I can add row 2 and row 3 and directly create 0 here, right? So what I get is 1, 0, 2, 0, 0, negative 2, 5, 0, 0, 0. Here, did I made a mistake? So now I should have negative 10 here. Yes, I should have negative 10 here, right? Because 2 times negative 5. So, okay, negative 10. So here negative 5. That makes sense. Negative 5 plus 5 is 0. Okay. All right. So again, that's a example of how do you find your mistakes. Okay. If you do it when you're doing your own problems. Okay, good. Now let's write down the equation. So let's write the matrix form of the equation. 1, 0, 2, 0, negative 2, 5, 0, 0, 0. See, we all are humans. Okay. We can do mistakes. It's very, very common to do mistakes in Gaussian elimination. So that is why I highly recommend you to do all the problems in the notes and please watch all these videos. Okay. All right. So let's write down the equation set. So we get K1 plus, so from here K1 plus 2K3 is equal to 0. Negative 2K2 plus 5K3 is equal to 0. Okay, so using the second relation, we get 2K2 is equal to 5K3, right? If we take this 2K2 to the right, let's switch left and right hand side. So K2 is 5K3 over 2. So what is a smart choice for K3? 2, right? Because you get rid of a fraction. So when K3 is 2, K2 is 5, right? And then K1 will be, K1 is from the equation negative 2 K3. So K3 is 2. So negative 2 times 2 is negative 4. So this is capital K1 related with the eigenvalue 0. Okay. Now we move on to the repeated eigenvalues. So the repeated eigenvalue here is 5. So 5. So let's write the A minus 5I matrix and solve for the natural eigenvector first. Okay. So here a minus 5i will be, so a, let's write the a first. A is 5, negative 4, 0, 1, 0, 2, 0, 2, 5. Now a minus 5i is, you subtract 5 from the diagonal. Here 0, negative 4, 0, 1, negative 5, 2, 0, 2, 0. So this is a minus 5i matrix. Now you want to solve for little k1, little k2, little k3. Okay. All right. So now what you're going to do is you use the Gaussian elimination. 0, negative 4, 0, 0, 1, negative 5, 2, 0, 0, 2, 0, 0. Now if you look at the first pivot position, it is bad, very bad, because we cannot afford this. We cannot have 0 as the pivot position. So let's switch row 1 and row 2. Okay, so we switch row 1 and row 2. So then what we get is 1, negative 5, 2, 0, 0, negative 4, 0, 0, 2, 0. Okay, so this Gaussian elimination should be quick, right? Because see, here pivot position is 1, but you don't have to do anything with we automatically have 0. So here the second pivot position is negative 4. Now you want to create 0 on the 2. So what would you do? You would divide the second row by 2 and then add it to the third row, because negative 4 divided by 2 is negative 2. Negative 2 plus 2 is 0. So what you get really is 1, negative 5, 2, 0. Okay, 0, negative 4, 0, 0, 0, 0. Here this will be 0, 0, right? So this is what we get. A very easy Gaussian elimination. Now let's write the matrix form of the equation. 1, negative 5, 2, 0, negative 4, 0, 0, 0, 0, little k1, little k2, little k3 is equal to 0, 0, 0. So the three equations are k1 minus 5k2 plus 2k3 is equal to 0. Negative 4k2 is equal to 0. Now if you look at equation 2, k2 is 0, right? We directly get k2 to be 0. Good. So if k2 is 0, k1 plus 2k3 is equal to 0 from the first equation. So k1 is negative 2k3. So let's choose k3 to be negative 1, okay, and then k1 will be 2, right? Okay, so then the second eigenvector is k2. Now this is the natural eigenvector, okay? So this is the natural eigenvector. Now we want to find the non-natural eigenvector, the generalized eigenvector. I lost the word. Okay, I forgot the generalized word. So what you do is you solve the equation. The eigenvalue is 5. A minus 5i times k3, that is what you want to find, is equal to k2, this eigenvector. Okay, now the right hand side is not 0, it's previous eigenvector, natural eigenvector. Okay, so let's find out. So A minus 5y matrix, we already know it's 0, negative 4, 0. Okay, we had it here, right? 0, negative 4, 0, 1, negative 5, 2, 0, 2, 0. Little k1, little k2, little k3 is equal to, now the right hand side is 2, 0, negative 1. That's the difference. Okay, now here I encourage you to do the Gaussian elimination. Okay, this is not easy like in 2 by 2 case. Okay, so let's write the augmented matrix 0, negative 4, 0, 1, negative 5, 2, 0, 2, 0. Here 2, 0, negative 1. Here you have to do Gaussian elimination. Okay, now again the pivot position is, the steps will be same as the previous Gaussian elimination. Okay, the steps will be same as what you did for natural eigenvector, but your right hand side changes. Okay, all right, so it's not easy like 2 by 2. So the pivot position is 0, so not good. So we will swap. What is sweep? Swap row 2 and row 1. So 1, negative 5, 2, 0, 0, negative 4, 0, 2, 0, 2, 0, negative 1. Okay, now see, we automatically get zeros here. We don't bother them. So here the pivot position is -4. So let's divide the second row by 2. Okay, and let's do it slowly. 1, -5, 2, 0, 0, -2, 0, 1, 0, 2, 0, -1. Now we can add row 2 and row 3. Okay, all right. So 1, -5, 2, 0, 0, -2, 0, 1, 0, 0, 0, 0. Okay, now notice we can write the matrix equation. Okay, all right, we can write the matrix equation. Here 1 plus 1 is 0. Okay, that is why I get 0 here. Be careful, now you don't have non-zero right hand side. Okay, so you have to be very careful when you do the Gaussian elimination. Okay, 1 plus -1 is 0 because we had row 2 and row 3. So I think I should mention that. Okay, so let's write the matrix equation. 1, -5, 2, 0, -2, 0, 0, 0, 0, little k1, little k2, little k3 is equal to 0, 1, 0. Now this is the difference. Okay, you cannot just take the Gaussian elimination result from the previous natural eigenvector and replace the right hand side by this eigenvector and solve the equation. Okay, matrix equation. You have to do Gaussian elimination from the scratch, but it will be similar to the previous Gaussian elimination, but the right hand side will be changing. Okay, so be careful. So you have to do it again, not like 2 by 2 case. Okay, so now let's write the equations. K1 minus 5k2 plus 2k3 is equal to 0 and -2k2 is equal to 1. Okay, so now what do we get? So from second equation, it seems to be like k2 is -12. We don't have a choice there. It's already done for you. So k2 is -12. Now, then if we use that k2 is -12, then this is k1. -5 times -12 is +5/2 plus 2k3 is equal to 0. Now, k1 is -5/2 minus 2k3, right? Now we have to choose our k3. Okay, here it's not like we have two choices. Okay, this is different from case 1. Don't mix up case 1. Okay, here we directly get k2 as what? K2. Okay, here we don't have a misery like case 1 where we only have one equation. So let's choose k3 to be 0 because that's the easiest. Okay, because our eigenvector will not become 0, 0, 0. So choosing k3 to be 0 is not a problem. k1 is -5/2. Alright, so this is the generalized eigenvector. Now I don't like fractions, so to get rid of fractions, I can multiply the third eigenvector by 2. So then this is -5, half goes away, -1, this is still 0. Yes, you can do that, okay? Alright, because these two are the same. It's just this k3 is 2 times this k3. So they are the same copies. Okay, now let's list them, okay, because we want to write the general solution. That's also different. So the first eigenvalue is 0 and the eigenvector k1 is -4, -5, 2. This is k1. This is a non-repeated eigenvalue, so let him be like that. Lambda 2, 3 is the 5th eigenvalue. The natural eigenvector was 2, 0, 1. The generalized eigenvector k3 is -5, -1, 0. Okay, now let's create the 3 solutions in the fundamental set of solutions. Okay, all right, so what is this first solution? Let's choose the first eigenvalue, k1 times -4, -5, 2 times e to the 0t. E to the 0t is 1, so this is x1. Now create x2. x2 is k2 times 2, 0, -1 e to the 5t. Now do we add plus t times x1? No, right? Because this is a non-repeated one. So leave him be like that. That's alone. This eigenvalue is not repeated. Okay. So this is alone. So let him be like that. So this x2 is here. Okay, that's fine. Now x3 is k3, which is negative 5, negative 1, 0, e to the 5t plus t times now x2, 2, 0, negative 1, e to the 5t. Okay, so this is x3. Now, do we care x1 and write t square over 2 plus this k1? No, this is a non-repeated eigenvalue. Again, I am saying we don't involve that non-repeated eigenvalue in the business of repeated eigenvalue. Okay, let me put it in that way. So then the general solution is linear combination of x1, x2 and x3, which is c1, negative 4, negative 5, 2 plus c2. These are arbitrary constants, 2, 0, negative 1, e to the 5t plus c3, the whole thing, negative 5, negative 1, 0, e to the 5t plus t, 2, 0, negative 1, e to the 5t. Okay, so this is the general solution. Little bit difficult, right? Yes, but it is what it is. You have to practice. I highly recommend you to solve all the problems in the note. Okay, thank you.